Hello, this is Lee Natero. I'll be showing you how to create a one-sample t-interval for a population mean on the TI-89. We'll be taking a look at two different examples, one involving raw data and one involving summary statistics. Let's go down to Stat List Editor and hit Enter. You can see I've already entered the data in List 1 on my calculator. This data is for the high-resolution video terminal tension on the screen. The tension is measured in millivolts. Here we have 20 pieces of data from a single day's production. To create our confidence interval, we're going to hit second, F2. To access the F7 menu, we'll choose option 2 for a t-interval. Our data input method is data. However, notice if you hit the right arrow, you can see we could have chosen statistics if we didn't have the data and just had the sample mean and sample standard deviation. We're going to choose data, hit enter on OK. My list is stored in list 1, so I'm going to hit alpha lock so I can type in the letters that spell out the word list a little bit faster here. My frequency is 1 since I entered all the data values exactly once. And my confidence level is actually going to be 90%. So I need to go down here and change this to a 90% confidence interval. I hit enter on OK. And my confidence interval is displayed. Notice we have a sample mean, a margin of error. Our degrees of freedom is 19, which makes sense since our sample size was 20, and degrees of freedom is sample size minus 1. And notice it also gives us our sample standard deviation. Based on this interval, I can say that I am 90% confident that the true mean tension of all screens produced this day is between 292.3 and 320.3 millivolts. Now let's take a look at a different example. For this example, we won't be working with raw data, we'll be working with summary statistics. We'll be taking a look at another example from Chapter 8 of the Practice of Statistics. For this example, exhaust emissions were measured on 40 light-duty engines, and the NOx reading was obtained for those light-duty engines. To enter our summary statistics and create a confidence interval this way, once again we'll hit second, F2, choose t-interval option 2, but now our data input method is stats. I come down here to stats, hit enter, and I'm going to enter the sample mean, which is 1.2675. Go down to the next value here for sample standard deviation. The sample standard deviation for the 40 light-duty engines was 0.3332, and the sample size was 40, and we're going to construct a 95% confidence interval. So I'll type 0.95 and hit enter again. Here we can see our confidence interval is about 1.16 to 1.37. Our sample mean and sample standard deviation and sample size are listed as we had entered them. Our degrees of freedom is 39, and that makes sense since degrees of freedom here is 1 less than the sample size. And notice our margin of error is also listed for us. So based on this interval, I can say we are 95% confident that the interval from 1.16 to 1.37 grams per mile contains the true mean level of nitrogen oxides emitted by this type of light-duty engine.